Welcome, one and all, to February the 26th of this month at 3:30. It is the COMIT Happy Hour, and this week we have an excellent panel and several presentations looking at intelligent robotics. We're going to be welcoming in Kevin, Nikki, Katie and Fran on our panel a little bit later. First of all, what I want to do is to make sure you've all got your beer glass ready or your gin or wine. Personally, I'm having a nice cup of tea this afternoon because I've got to drive shortly. But otherwise, sit back, relax, enjoy, and I'm going to hand you over to Stuart. Over to you, sir.
Thanks, Ian. Welcome to everybody today. Thanks very much for all the attendees. We've got a fair lineup today. Really appreciate the questions I got in beforehand as well. Thank you very much for those. So for those that are new to COMIT, what is COMIT? Well, COMIT is a collaboration platform of owners, contractors, solution providers, and of course academia. We have a long history of developing and running demonstration projects with our members. We focus on increasing value through productivity improvement. One example of increasing value and adding value to the industry was a project that we developed recently with and in conjunction with one of the members, and that was a solution around the COVID-19 tracking on construction sites. It's currently deployed and the feedback is great. But of course, behind all technological initiatives in our industry is a simple goal, and that is improving productivity. Often the best improvements come from a combination of knowledge, process and technology. COMIT and its community is identified with the major barriers in our industry and has developed a unique opportunity to create enablers and the potential for beneficial change that would lead to cross-industry improvements. By being collaborative and only being collaborative with all of our stakeholders, we can create new ways of enablement through process improvement and ultimate demonstration projects. The long-term aim is to reduce capital project costs and a reduction in cycle times. Just a quick overview of how to use the system. You'll notice at the right-hand side of your screen, you've got the control panel. I'm encouraging everybody to fire the questions in as you think about them, and we'll get to the questions at the end. On to today's session. So I'm not going to say too much about this other than artificial intelligence and robotics are a very powerful combination for many things, but automating regular tasks inside and outside of the project setting. In recent years, AI has become common presence in robotic solutions from other sectors, and that's outside of engineering and capital projects. It introduces flexibility and, of course, learning capabilities in what we previously called rigid applications. So I won't say any more about that because we've got a fantastic lineup that will give you a full overview. Before I get to meet the team, what I have got is some panel questions that I would like to share with you. So just bear with me a second. I will bring the panel questions up. Sorry, the poll questions, beg your pardon. I have the first one. Is your company looking to or using robots on site? Let me launch that. And we've got multi-choice.
All right. So,
can everybody say
company looking to or using robotics on site? I suppose, you know, whilst people are looking at that, it's not necessarily just purely on a construction site, but any workplace, I suppose. Or if we're working from home, are we looking to use robotics in the home? Certainly there's some pretty good labour-saving devices out there. Yeah, so I would say, I'd say
okay.
I'm here to learn. So let's see what the answers were.
You might be surprised, Ian. Okay, there we go. Can everybody see those?
Yeah. It's interesting that 30% there are actively using drones and robotics on their sites. That's a good number. It's nice to see.
Fabulous, thank you. Okay, so let me hide that, bring the next one in. Do you think robotics will be difficult to integrate onto site? So it's three very simples, yes, no, I'm not sure.
Oh, that's an interesting one. I think the human robotic interface will probably be the most difficult thing, because I can think of many technologies and innovations over the years that have been sabotaged by the human element on the construction site by using their brand new iPad as an bacon tray, or a one of those digital pens to stir their tea, because they didn't want to see that kind of thing taking over their jobs. So I think it's going to be a cultural integration problem.
Okay, thanks to everybody for voting on that one. You should see the results now.
That's interesting.
Yeah.
Well, time will tell, I think. I watched a fabulous little video whilst that's going on. Whilst you're bringing up the next one, Stuart. A fabulous little video on a robotic sort of machine that climbs warehouse shelves and takes things off the shelf and brings it down. I was thinking, how easy would that be to replicate, but using scaffolding rather than warehouse shelves? Anyway, so what's the next question?
Okay. Can you see that one? What aspects of site work would you suggest robotics will be best applied to?
Manual handling is obviously a massive one, because that's where a lot of the injuries come from. Especially if you're able to lift more using robotics. Site safety risks.
Yeah, the biggest one I think is just at the moment is repetitive aspects in quantity and whatever. Yeah, but it's even. I'd like to say it's evenly spread, but yeah, reducing quantity and duration. Repetitive. Let me share the results of that. Can you see that?
Yeah, I think you're right there then, Stuart. Reducing the quantity and repetitive works. I think that when you're repeating something time and time again, you get either bored or your concentration goes, and then that's when accidents happen, quality gets reduced, or you just can't find people to do tasks like that because they're dull. So yeah, being able to do that will be quite handy.
Yeah. Next question, second to last. What would you convince your company of the benefits of AI and robotics? Should be able to see that now. It should be, how would you convince? But
how would you?
I think you get the drift.
Yeah, so how would you convince your company the benefits of AI or robotics? Whoa, it's got to be return on. Show me the money every time. If I can't see a value statement in there that's going to give me something, some sort of tangible figure that I can grasp hold of, and say if I invest X, I'm going to get X plus Y back, then it can be a difficult conversation, especially if it's a big investment.
Yeah. Okay, thanks for voting on that one. Let me share the results. I'll be surprised on this one, but yeah, Ian, I think I agree. Return on investment.
Yeah,
that's the lion's share.
Brilliant.
Okay, next question. This is the final one. When do you feel AI would bring most benefit during the project life cycle? Should be able to see that now.
Blimey. Well, I'd like to see it, and I think it probably being the most benefit into pre-construction, purely because proper planning prevents, well, yes, proper performance. And I don't think there's enough money or investment or time and effort or value put into the pre-construction, into the planning cycles and things like that. Because we get that right, then we're going to save a lot of money. If we can put AI into that to speed that up and make it more, more repeatable process, I think that would bring a huge benefit. But we'll see. We'll see. What a
the audience agrees, Ian. You're absolutely right. There's the results: 36% pre-construction.
Because the saying goes that fail to prepare, and you must prepare to fail. So pre-construction for me has got to be there every time.
Yeah, absolutely. Okay, well, thanks for participating in that. Very interesting. There's a couple of points in those polls, and if there are some individuals want to get involved in a couple of projects, then we can certainly discuss. Thank you. Okay, so on to the next. Meet the team. So we've got Kevin, and we've got Nick, we've got Fran, and we've got Katie. Kevin Blacktop began his career in the automotive sector in engine and design development. He moved to Network Rail in 2005 to develop major rail enhancement schemes in the West Midlands, including Birmingham Cross City line extension to Bromsgrove. 2012, he joined the research and development team, leading the strategic university partnerships, and was the technical lead for the EU Sustrail project. He also represented Network Rail in the EPSRC Autonomous Intelligence Systems Partnership Programme, that's a mouthful, which began his involvement in robotics. Next, I've got Nick. Nick is a robotics engineer working with the UK Civil Service. He's worked in a number of different robotics organisations in the UK and abroad, and is now helping to introduce off-road autonomous vehicles. Then we've got Fran. Fran is from Agile Handover. He's an avid emerging technology specialist with a long career of leading organisations in research. He's an evangelist for the future technology. Over the last decade, Fran has presented at many COMIT events and is well known for his engaging conference work in developing and managing future tech. He also runs at Christmas time the Toys for Techies. So the next webinar we'll have next year will be Toys for Techies, Fran. We're looking forward to that. Fran was also a conference chairperson for the launch and creation of Robo Universe. He was one of the first to introduce and show flying robots, drones, before all the cool kids got them. In 2006, he was awarded the first Fiatech Star Award in recognition of his contribution to industry. He also works with the Construction Industry Institute on the Breakthrough Strategy Committee. His work currently involves providing strategy and bridging the connection of data from construction to owners, operators, and facilities. And then we've got Katie. Katie's from Graham Construction. She's the lean deployment lead. Katie has a wealth of experience in change management, lean deployment, and performance improvement. Katie joined Graham in 2017 as the lean manager, where her role is to lead the lean development strategy. Their mission is to develop or deliver what customers require right first time, every time, within safe and sustainable continuous improvement business. The vision is to increase value and remove waste from the processes. Katie also delivers and coaches staff in lean techniques, including collaborative planning. So welcome to the team. It's great to have you here today. As I said, we've got a wealth of experience here, and I'm going to start off with Kevin. So Kevin, if I can hand over to you for the first slide. Away you go, Kevin.
Right, well, do you want to go straight on to the next slide, actually? It's just a picture of me at the moment, so.
Sure.
So good afternoon, everybody. And so I'm the a current chair of the National Robotics Network. So there's a little icon on the top right corner that you can do the QR code for to get to the website, or there's a website address below my name. So please get in touch. Can I have the next slide, please? So what is the NRN? So it's basically a end user driven group of organisations from multi sectors. It also includes the supply chain, and it includes the academics as well, because we want to increase the uptake of robotics and AI technologies to basically make the UK be able to better compete on a global scale. And we want to encourage open innovation because we want to share the cost and we want to share the risk, because some of the things that we want to do aren't readily available at the moment. So this is a way of achieving that aim. Next slide, please. So around the question mark is some of the sectors that our members of the NRN are currently engaged with. And sometimes you might think, well, what could the links be between construction, space, transport, agriculture? It doesn't, first of all, maybe jump out that all these sectors are quite closely aligned. We all need productivity, we all need health and safety, and we all want to drive quality improvements. Something the manufacturing industry's had for a long time. It's used robotics and automation to great effect. Have the next slide, please. But the thing that kind of drives those industries apart from many of the others is really we all work in unstructured environments, i.e. we don't control everything. We don't bring all the parts in, we don't control the weather, we don't control the humidity and all of those sort of factors. So if I take my industry as an example, here's the rail, and the construction industry obviously is a major part of this. But other infrastructures have the same sort of conditions. So number one is it can be quite a dangerous thing to work on. You can work at height. You can have power cables around. You can have trains running around. You can also have all the usual contaminants, ballast. There's weights. There's water. So there's quite a few opportunities to have accidents and incidents, and the rail industry unfortunately did have a big problem with accidents. It's managed to do a lot to make it a safer environment. The accidents trackside now are coming down significantly, and because it was unacceptable before. But the thing is, we also need to drive quality and we also need to drive productivity. And when we want to do these things, the railway, for example, is a service industry. People want to ride on the trains for as long as possible. You want the services starting in the morning as early as possible, running late at night. We want to run more trains than ever before, which means the infrastructure wears more, or the degradation is more on the rail industry. So it means that it's very difficult to actually do the inspection and maintenance that we have to carry out. For example, every single millimetre of the track, the rails, need to be inspected for cracks. And if you want to work at height near the running railway, you invariably have to, in the windows of opportunity you invariably have to put up, say, scaffolding in one visit. You might then do the inspection or the piece of work and in another visit, and then come back for a third time to take the scaffolding down. So these are examples of kind of the productivity loss that we can suffer from. So really, it's about how we can use robotics and AI to drive this productivity and safety. Can I have the next slide, please? The other thing is, we all can see the business case for robots in a factory. Every few seconds, they're going to be doing the same repetitive job. But the chances are, in our unstructured environment, we still want to repeat these processes. We still need to be able to continuously build bricks, or we continuously need to get up and clean things or inspect things. These repetitive processes, we don't do one-offs, but we seem to think of robotics and AI as unsuitable for this sort of flexible working that we need. Have the next slide, please. So we still have these common challenges. So regardless of your sector that you're in, we still have to work with the environment. We still have the product and processes that we would like to do. We need to train people to use this technology and get them used to working with it. We have sensing problems, manipulation problems, mobility problems. But you know what? We all have the same ones. It is always difficult to get where you want to be and do this piece of the activities you need to do. Go on to the next slide, please. So the real questions, as far as I'm concerned, are: can we make robots affordable? Useful robots affordable? Can we develop a sustainable supply chain, and can we encourage adoption? Now, all of these things are linked together because it's about having, if you can get products available that are able to be widely used at flexible robotics, you can then have a supply chain that can make a profit out of supplying these products. They become more affordable. You know, we don't have construction or space only computers, laptops, but we seem to treat robotics as something that's very bespoke and therefore very expensive. So the NRN is all about collaborative working and trying to break down these barriers. Okay, next slide.
Oh,
we're done. Thank you.
Thanks, Kevin. Over to Nikki now.
Thank you. There we go. Can you hear me okay?
Yes, loud and clear.
Excellent. Okay, next slide, please.
Okay, there we go.
Okay, so I'm going to be speaking to you about what we've been doing in government with regards to robotics. And the key thing I want to highlight is that there's opportunities for collaboration. Slide. So we have been experimenting with unmanned ground vehicles in the defence sector, and this is something that I want to share the lessons from. I want to help you to understand why this matters to the construction industry, explain some of the challenges we've had and how they're applicable to you, and show that, yeah, there are opportunities available. Next slide. So background, why have we got into robotics? And I'm going to be coming at it from a distinctly Army perspective. So we've known that robotics has been coming along for a very long time now, but only relatively recently has the Army decided that we're on that point of the maturity adoption curve where we should start getting into this type of thing. So we ran an experiment in 2018, and on a high level, it showed that robotics was at a level of maturity where we could start using them. They're at a level of technology readiness level that we could start using them. So the next year, the Secretary of State for Defence announced a number of projects, including a project called Robotic Platoon Vehicles, which is what I will draw most of my experience from here. And a key thing about this is that we don't know the full requirements for these systems. It's not like we're procuring an aircraft carrier or a tank or an aircraft itself. We don't have 100 years of lessons or data to draw on. So we need to think about this in a new way. And in particular, we need to treat this as an experiment. So the idea behind this is that we're going to conduct experimentation to learn about the requirements for these systems in order to then potentially go ahead and do a full procurement of them. So we've procured 5 different types of these vehicles. These are RPVs, and we're going to give them to a user. We want to take them out of the lab, out of the trials environment, and actually give them to the people that are going to potentially be using them in future. And we call this a process. We call this process prototype.
Oh,
Lost your sound, Nikki.
Type warfare. You're giving systems that are still at a mature level, but
It's all right, you're back.
carry on, Nick. Oh. We lost your sound still.
Say again?
Yeah, got you there.
Fine, carry on.
Yeah, I'm back. Can you move to the next slide, please, Stuart?
Yeah, there you go.
Thank you. So that's the overall aim of the experimentation, to give Army headquarters a bit more information on whether UGVs are actually going to be useful. Yeah, next slide. So key points, the systems we're using are for load carriage. It's all about experimentation, so there's not going to be a winner at the end of this. The winners are actually all of us. It's both industry and government. The way we're doing this experimentation is that because this is a new capability, industry is going to learn just as much as we, the adopters, are going to learn. They don't necessarily understand our use cases fully, and we don't necessarily understand fully what they can deliver. So it's very much a collaborative process. As I mentioned, these things are prototypes. They're not actually the finished product, and it's about the capability as a whole, not a specific type of robot. All completely new. We don't even have, we've never procured a system in this way before. The technology's all new, and actually because of that, it's a great leveler in the Army, because no one has any experience of them. The rank structure is much reduced because no one's got any experience of these systems. I'm sure that would be the same on your site as well. Yeah, we're procuring this tech in a new way. Next slide, please, Stuart. So that's a broad way that we're procuring these things. It's called spiral acquisition. So you still go out to competition. You still send out a set of requirements to industry and say, here's broadly what we're after. You then select the top however many companies that you're willing to procure. You place your delivery, you place your orders, they get delivered. You then train your personnel on these systems, and that's key as well, because at the moment there's no template on how you train people on an unmanned ground vehicle. You then conduct your experimentation, you collect those lessons that your users give you, and you run the spiral again. So you collect those lessons, refine your requirements document, and then you put it out to competition again. And you typically do that over 6 months, a year. You might turn the handle a couple of times and then send it off and say, it's at this level, that we're going to fix it at this level of maturity now. Let's go out and potentially do a full procurement. Next slide, please. And it's all because we can't learn from a blank sheet of paper. We don't have that baseline of robotics in the past that we can draw from. We're doing this experimentation. It isn't always perfect. We're doing this experimentation to get that baseline that we need. Next slide. And those are the systems that I'm talking about. So the things that we're doing, they can be remote controlled, they can be teleoperated through a camera, or the systems can be what we call waypointed. So you will have a map in front of you, you'll input, you'll draw on the map where you want the system to go, and then it will attempt to follow that route. And they also have obstacle detection and avoidance mechanisms on them as well. So if they encounter something in the world, they will attempt to drive around it. Well, I don't really want to focus on the technology itself. I'm more interested in the experimentation process and what we can learn from them. Next slide. So what are our findings? We have found that this new technology requires different methods of procurement. We need new ways of collaborating with industry. And I look to the catapult centres that are out there in civilian industry. I look to the robotics hubs like RAIN and Orca as excellent models for connecting end users with academia and industry. And that experimentation is key for you to collect those lessons. But how will all these different technologies interact as well? You've got AI, you've got virtual reality, you've got how are you going to get power on site, you've got connectivity issues, you've got different types of radios. How do these things come together to give you the capability that you want? There are certain underlying technologies that we all need to develop. I'll come on to digital twins, for example, in a little bit. And we also need verification and validation methods, V&V. So how do we prove that these systems are going to be safe, and how can we prove that they're going to behave the way that we want them to? Those processes aren't necessarily there, and one of the real key pieces is we need the skilled people. And the way I think about this is that it isn't really about the technology. I don't really mind it's not less about things like, oh, can you move that sensor there? I need this type of, I need it to go this many miles. Actually, I know these things are probably going to come along in the future, and we need people with the right skills. So this experimentation is getting people in the mindset that these systems are coming, and in the future, when we potentially do a full procurement, through this experimentation, we're going to have a cadre of people that are already familiar with this technology. Next slide. But the real big hitter, and was one that most people in defence hadn't really considered, was trust. And when I say trust, I mean between the human and the machine, and vice versa. So how can the human trust the system to perform the task that it's been asked to perform, and how can the human trust it to do it safely? On the flip side, the robot's got to trust the human to not do anything overly unexpected. So, for example, the robot isn't expecting the soldier to lie down in front of the robot. It's both ways, and I'll come on to that in a little bit more detail. Next slide. So summary for this part of the presentation, from what we've done, RPV is about procuring a new capability, so a robotic type system in a new way. So there's a double whammy there. Emphasis on experimentation. That's the only way we really see that robotics is going to be introduced into the army. And we're actually giving it to 2 units to experiment with, to help us learn those lessons really, really quickly. So one thing to emphasize actually is that we give this equipment to the users, but we provide limited logistics support. So what we actually want is getting those lessons out. So when they start running out of spares, tires, sensors, when they get bashed around a bit, as long as we've got the data that we need in terms of the experimentation, we're not there to logistically support them. And this is absolutely helping to shape the future of the British Army. We don't want another France 1940. We don't want another HMS Prince of Wales repulse moment where we've been surprised by people using technology in a new way. And from a civilian point of view, the analogy is Netflix. So they got in there early. They realized that you could stream video over the internet. They realized how you can do it well, and now you don't see people posting out DVDs anymore. Next slide. So why do I care about construction? Why am I interested in it? And as Kevin's already alluded to, they're relatively similar, and this is the case for a lot of different sectors. And construction in particular, they are unstructured environments. You've got a dynamic, you've got people moving around, and with mobile robots, you're not always going to get perfect connectivity with them. You're not always going to get GPS. You're not always going to get comms with them. It'll drop in and out. And as a result of these similar issues that we might have, there's going to be similar technology solutions. I think we can both learn from each other. The tech has applicability in both areas. So if construction advances in remote or autonomous plant equipment, I'm going to be interested in that. If we develop ways of verifying autonomy, that's going to be of help to the construction industry. Next slide. And a key area is going to be digital twins, and that's where I think construction has actually got a bit of an edge over people like myself. You guys are already, to varying degrees, relatively familiar with this theme. Even if you haven't adopted it yet, you know that it exists. Whereas in defense, digital twins is a very new term. I have to explain it to people on almost a daily basis. And it's so important because robots will feed into your BIM and your 3D visualization. Digital twins will enable planning of robot operations. So if you're going to deploy a robot in an environment, you can actually measure the gaps between objects. You can plan the route that your robot's going to do before it even gets onto site. And then once it's out in the real world, you can track that system on a 3D model. And another really important thing that 3D visualization brings us is the ability to simulate. So AI needs training, and people are now turning to simulation methods to train their artificial intelligences to recognize things in simulation first. So can it recognize certain assets? Can it recognize people? And to do this in all kinds of weather conditions is very hard to do in the real world. So people are turning to simulation. And I think that's where construction does have an edge, because you're already leaning into that. Next slide. So I've stolen this from one of my bosses, and these are the pillars of robotic implementation at a very simplistic level. And I like to think of this in terms of a steam engine. So you need the skilled people to operate the steam engine. You need water and coal. That's your raw data that's going in. That's it. And in the case of robotics, that's information from your environment going in. And then the technology, so your hardware, your software, your algorithms, turn that raw data into useful output. I think if you're going to break it down, these are the three areas for me. Next slide. Experimentation is key, as I've already said. I think it's a double-edged sword, because on the one hand, you don't want to be too prescriptive in where you think robotics could be used. From our perspective, we didn't have a particular use case that we thought robotics would be good for. We just knew that the technology would have some kind of use. So yeah, think about your use case, particular use cases, but also keep an open mind. You don't know how these systems are going to disrupt your industry. So first, obtain a baseline. How do you do things currently? Then try out those same processes, but with the new kit. And then we give our soldiers, we allow them to use these things freely. So you give them the new kit and say, how would you use this? Ignore what you've been taught in the past. Actually think freely. And you might think that, well, I can't do that on my construction site, and that would be true. But so what we do is we give the soldiers bespoke experimentation periods. We don't give them to them on existing exercises, because if you start throwing in new features, it might cause them to fail that exercise. So we give them bespoke experimentation exercises where we can really dive into that and we get real value out of it. Next slide. So what are the challenges? I'll jump into a couple of these in more detail. Culture, I'll go into more detail on. You've got to manage your expectations, people's expectations in terms of technological maturity. These things can't do everything yet, and yet they still have good uses in certain environments and can bring you value. But you've got to match people's expectations with the technological maturity and understand what the systems can and cannot do. Currently, there's a distinct lack of process and guidance, particularly in UGVs. The drone world is very well regulated. You know, there's drone pilot licenses and regulations. UGVs were not quite there yet. And as I've already said, verification and validation certainly is a challenge, but there's lots of people working on it. Next slide. So culture, and this is definitely the trust issue. You've got to manage people's expectations in terms of the technology. So saying what it can, but most importantly, saying what it can't do. So for example, when we come to our soldiers, we say that you can traverse this ground really well, where the robot might struggle. However, the robot's going to allow you to carry a lot more equipment. So they've got to understand what the machine can and cannot do, but that also that it's going to provide benefits. It's going to augment the team, make them more effective and better able to complete their mission. And we've got a number of programs in place to help to understand that cultural change and to understand how we build trust between the user and the machine. Next slide, please. Yeah, verification and validation. How do we make sure that these things are safe? What processes do we come up with to accept these systems into service? And as I said on the digital twins slide, simulation is going to be a really big part of that. And we're going to have to come up with ways that we can test these systems, and we're going to do that using what we call scenario-based testing. So we'll put the robot in a virtual world and have virtual troops moving around it to see how it reacts and see if it reacts safely. But we still need to come up with those scenarios, and that'll be the same in many sectors as well. So for example, in autonomous vehicles, what happens if a vulnerable user walks out in front of the vehicle? How does the vehicle respond? Next slide. So I've said about the challenges. What do we need for robots to grow? We need representative environments. We need testing grounds. We need things like mock construction areas. We need things like mock battlefields with their trenches and their barbed wire. And that'll be the same for every sector. They will each need representative environments in which to train and understand and experiment with robotics. We need communities of interest like the NRN. We need cross-sector collaboration, and we need these opportunities for collaborative experimentation, because we're all going after the same sorts of issues, particularly when it comes to outdoor mobile robots. And we need new relationships with existing organizations. I'm certainly starting to lean into the civilian sector, and organizations like COMIT a lot more. Next slide. Yeah, and these are the kind of people that I'm talking to. So this is just to show that there's plenty of people out there who are already doing this, and we can all learn from each other. Next slide. So yeah, there's plenty of opportunities out there, and I'm keen for us to come together and start talking about how we can help solve each other's problems. So I think there's scope for things like joint training areas, for collaborative projects, and definitely for cross-sector collaboration. Yeah, next slide. And so these are the things that I'd like you to have a think about. What are your potential use cases? Where are the opportunities for collaboration, and what are the blockers in construction? I'd like to see them drawn out in the panel later. Thank you very much. That's the end of my presentation.
Well, thanks, Nick. That was excellent. Some really nice elements to show what robotics is all about, and also what you're doing. Very interesting stuff. So thanks for sharing that with us. I'd like to invite Fran up now. Fran, are you ready to go? Fran, are you there?
Here. I'm unmuted.
Do you want to put your camera on, Fran, please?
I'm waiting.
There we go.
Hey, here we are. Okay, great.
Over to you. There's your first slide.
Great. So I want to take a step back. And by the way, Nick, great stories there. I put a couple comments in. The U.S. has been doing a lot of things with military robotics. They've had the DARPA competition, which the first one really launched the whole self-driving vehicle movement from everything that they learned there. So I do see military contributing and sort of leading the way in sort of the robots. And the second one they did, the more recent one, was in a dangerous area where a robot had to literally climb steps, open doors, turn knobs, do things that would be a challenge for a human even. So great stuff. I also put a comment that, for the last 10 years, I think, the U.S. Air Force has been training more drone pilots than they've been training regular pilots. In fact, they have a shortage of drone people to fly. Anyway, I'm going to take a step back and talk about what is robotics. I've been really lucky enough to be involved. In fact, when I was in college and started, I thought, wow, robots are really cool. I did a lot of stuff in math. I don't know if you can see this. This book is probably older than me. But, I got it. And at that time, the type of coding was all basic. So it was very elementary, but I had an interest. This is another one. In early AI, the neural networks were sort of the big thing, and those and expert systems, and how to build your own self-programming robot. So what is robotics, and how does it impact the construction and infrastructure industries? First of all, robotics itself is a collection of technologies. It's really the intersection of sensing and movement, data collection, real-time data analysis, and reactions to an environment. So I think that last part oftentimes gets lost. The idea that it senses and reacts. And it does a lot of things very, very, very quickly in doing this, probably eventually even surpassing what a human can see and understand. Robots also can be too. They can be standalone and self-directed, or they can be human assisted. As we just learned, it seems like these robots that they're pilot testing there in the UK are more sort of assistants. They're back carriers. They're a mule, electronic mule of some type. But these things can be set off on their own to go down through a trail to sense for mines and bombs and everything else. Size matters, and the size of robots. I think we have a misconception that robots are some human figure or some animal-like figure, but it comes in different sizes and it matters in many different ways. In fact, you can really think of a robot, a digital infrastructure or a digital twin model, as being a robotic combination of information together in working with buildings, and people, facility management, are working with buildings. It also involves the overlap of many other disciplines. AI and robotics are closely related. They're joined at the hip. But it requires mechanical engineering, electrical engineering, software, human interfaces, location technologies, and a whole bunch of other sciences. The really big change, and most people don't even think about this, it's not talked about a lot, but is really process automation. Now, we all know in the construction industry and in building and facility management, we're all trying to build processes step by step. How do I do this? How do I build it? How do I assemble? What's the time schedule? What's next? What's behind? All that stuff is going to be, I guess, jump-started by what's called robotic process automation. So it's a non-physical type of robot that's going to thrive. And I think that's something that should be looked at. Next slide. So when I talked about sizes, they come in all sizes. A robot can, in my mind, be totally invisible. And invisible meaning that there isn't any moving machine or something out there, but it is sensing things. It is a big electronic brain. If you really want to jump ahead on AI and you want to jump ahead on software and thinking and things like that, the real hotspot is going to be quantum computing and using quantum computing. And that's real today. You can learn that and do that. The other thing is the fixed mechanical. Typically, we think of these as the assembly line type things, where we have arms picking things off, seeing things. Typically, you think of the automobile industry assembling cars. We talked about moving and roving, both in the air, the land, and the sea. I think with the launch of drones and also the self-driving car movement, we've developed more sensors and more understanding of gathering information from sensors from those two industries over the last few years than we've gained probably over our lifetime so far in understanding and moving with robotics. And then we got to think of big machines. We all know about this whole self-driving car thing, but there are self-driving large construction machines. You can go and put in information from a CAD drawing today, plug it into a machine, and have it do cut and fills on the landfill. That's real today. Now, that sounds very expensive, but it's very detailed and it's very safe in the sense that you're really programming it based on what you're trying to do. And the self-driving, and it's not just self-driving. I show a truck here, but there's all types of these cars. Probably one of the leaders in this is Doosan over in Japan. South Korea, that has a whole collection of things. If anybody wants more, I'll send some links or something to that if you're interested in seeing that. I did a couple years ago now a session on, and it was really at a sensor conference, but robots really heavily depend on sensors. And obviously the two biggest, I think one of the two biggest areas that we've seen growth has been in visual sensing, image sensing and understanding image sensing, and also in voice. But you may say, well, what about nose? What's a nose? Well, there are sensors, and there are going to be more robotic sensors potentially going around and sensing. And we have these sort of sensors now with carbon dioxide, but sensing gases and things like that in different environments. In fact, what's really interesting now is Qualcomm has done some research and came out with a way to create sensors, which is interesting, and you'll see different applications of that. So think about the sensors. The sensors are a heavy part of what drives the robots. Next slide. So AI, I'm going to jump quickly into AI, and almost all robots include some AI component. We may debate exactly what AI is, but it has an adaptable type program, not a fixed type program. That's sort of the difference of what makes AI different than traditional program. Traditional program will give you the same answer every time you sort of put in the input. An AI program will evolve over time, and it may not give you the exact answer or the right answer, but it will get you very, very close. And the other big thing is AI is heavily dependent upon big data, and big data involves doing all these things. I'm not going to go through each of the V's here, but you really need to start at the beginning and start to think about collecting data. Data is the new capitalism. Data is the new gold. Next slide. I'm not going to, I gave you a link here. It's Count Things, and it is on both Apple iOS and Google Play Store. And basically, it's a simple application. It's an AI application that will look at an image and will be able to very, very accurately count things. They have sort of a free version. Will count things like change on a countertop or whatever, or pipes, or lumber, or anything, even microscopic things. So I'm not going to do this, but try this at home or try this at a site and see how it works. This is a good example of simple AI and image recognition. Next slide. Oh, you probably clicked, yeah, you clicked on me or something, my LinkedIn thing there. This is my last slide, actually. I'm doing work with Agile Handover. We work in dealing with data from the build, design, construct, and the handover to facility management and integrating all back-end silo systems. I also, the next issue of the AFE journal there is going to include several articles on robotics, and we'll have an ongoing series there. I work with them as associate editor. There's my Twitter and LinkedIn, and not necessarily related to robotics, but working with a group of people on publishing some education and training and sessions on IoT/digital twins. That's it, I think.
Okay, thank you, Farhan. That was superb. I know it was only brief, but some really good information that I'm sure those tuned in today will take away. I'm particularly interested in the counter there. I'm going to go away and try that later.
Yeah, everybody should try it. Simple.
That sounds fantastic. Well, what I want to do now, if I can, is just go very quickly to the questions. And if I can just click on to the next slide. Katie's going to jump off the call at 4:30. It was she's got another engagement after this, so I'm not sure it's another webinar or something else. But thanks for joining us, Katie. And we've got a couple of questions. In fact, we've got several questions. I'm going to alternate between Ian and myself, but I'm going to aim a couple of questions at Katie. Katie's with a construction company that's working predominantly in the highway sector. And one of the questions I've got for Katie is, why do you think adoption of robotic innovation has been slow within the highways sector? Katie.
Hi, good afternoon, everybody. I think to answer your question, I think there's quite a lot of reasons, and perhaps Kevin's covered quite a few of them in the rail sector, but I think why we struggle first and foremost is historically we've got very, very low margins. We're talking margins of 3%. So therefore, when it comes to sort of having that money to invest, it can sometimes be quite difficult. I think as well, historically, we've had a problem with like pipelines of work and visibility of it, but thumbs up, that's now starting to change, especially in highways, because we're moving towards sort of framework sort of working and getting the contractor really involved early on in the design. And we've got visibility of that sort of pipeline of work. So that environment is starting to come together now. But I think typically in construction, we are really looking to some other industries because another sort of blocker really is as well experience. And it'd be unfair for me to say that we aren't dabbling with AI technology. You know, we do use drones. We do radar scanning, and you know, we have BIM models where we look at linking that with planning element and visualization. But what we're really interested in is, you know, our worker safety and how do we remove some of these people from repetitive tasks and also being in, you know, quite confined environments. I think as well, the final bit really, logistically, you know, we're dealing with live traffic. We've got road users that can come into our works, and we can be working in very, very slim, confined environments. For example, the M60, I was working on that contract, and that motorway has already been extended. So in order to put the smart motorway in, we're working in a very, very restricted environment. So if something went wrong with the planning, somebody could get stuck behind, you know, a vehicle in terms of doing work, and that could delay the whole programme for the day if the planning wasn't done and the logistics wasn't right. I think working at cables, and the big one for us is weather, as always. So, and I think as well, being a main contractor, we're not the people necessarily adding the value. So what we do need to be doing is supporting our supply chain to be sustainable, as Kevin alluded to. Thank you.
Well, in a lot of innovations moving on in the construction industry, there's normally some sort of incident or something that's happened that is a kind of like a catalyst or a key thing. Is there anything that you can think of, whether it's in the highways world or the infrastructure world as a whole, that you would say is something that we need to look at and go, well, that wouldn't have happened if we were using robotics or unmanned ground vehicles or something along like that? Is there something in there?
I think for us at the minute, I'm kind of involved with fair space a little bit. So we're looking to, like I said, other industries such as space, because space in particular, their long-term vision is to build roads on the moon by 2030. So it's up to them to gear up their robots to be able to do that. Therefore, they want to try and trial the robots to work and be able to build roads in highways. So that for me is like a big win-win. But at the minute, you know, we have got some cultural and financial challenges, but some of the things we're really looking to work towards is using things like the exoskeleton, drones that are perhaps going to go out and fix potholes. But then, like I said, we've got some of these, you know, quite harsh environments that we need to take into account. How's the weather going to affect it? Unstable ground, but equally, that's what they're going to have on the moon as well. So yeah, really looking forward to just trialing some of them. But I think the only way for us to move forward as a main contractor is to do this in collaboration with Nicholas, with yourself, and other industries.
Sure. Katie, can I ask you one question? Thanks for answering that. You also answered the second question I had for you as well about the benefits. But there's one thing I want to ask you is, how are you convincing the powers that be within the organisation that this is the way forwards? What are you doing to get this across the line and say, right, this is where we need some money to invest? What are you saying to them?
Like I said, we've been trying to get involved in bids. Highways England, obviously, you know, are the biggest asset owner in the UK, so they're really pushing for this sort of innovation and things like that. And we've got now moving towards alliancing sort of partnerships to kind of work together to do some of this stuff. And I just think really that for me, the benefits speak for themselves. We're in an industry where we've got a lack of resources, we've got a lack of materials. Historically, you know, people are getting injured. We shouldn't be putting people to work that are getting injured, and it's not nice for anybody to work on a motorway in harsh environments in confined spaces. So, you know, there's a need there. We've got huge programs of work. So yeah, it's just about.
Thanks for that, Katie. I'm glad you mentioned the weather and the M60 in the same sentence, because that can slow any program down. I can vouch for that.
Yeah, I get the blame for that quite a lot.
Yeah, I'm sure. Well, thanks very much. I think we delivered you on time. We have got quite a few questions here, though, Ian, I notice. So,
Stuart, I was just going to say, there's quite a few questions that are specifically before, Katie, coming in on the questions.
I'm okay for the minute. It's just, yeah, I'm okay for the minute. I can stay on a little bit longer.
Okay.
What we'll do though is we'll get them out of the system and put them to you, so you can get in contact with those people.
Yeah, that's perfect.
We'll put up the answers by the video, so we can come back to them. Because I'm conscious that there's lots of questions on here for Nikki and Fran and Kevin. So, Stuart.
Hey, Katie, just had a comment. A few years ago, I think it was out of Georgia Tech, a phone application that was sort of a crowd sharing AI. Basically, you would open this application on your phone, and as somebody was driving, and have it on your seat. And as somebody was driving, if they hit a pothole, the phone would measure the vibration and also the location. And they would then crowd share and collect that information. And instead of having a troop of people going out and looking for potholes on the road, they had the crowd sharing intelligence of where there was vibration and potentially either a pothole or something else that they hit. And I have to look it up. It might be on, you know, the App Store now still. But this was probably about 5 or 6 years ago when I heard about this. Brilliant application.
It sounds good. Sounds good. To be interested.
So going from the top then, Ian, will question number 1, which was aimed at Nick, did that get answered? I don't think it did it? Nick?
No.
Right. So Nick, are your experiments tax deductible? Research and development tax deductible?
Oh, that's a commercial question that me as a simple engineer wouldn't know, actually. No, I don't think they are. But that is a good question, actually, because I think they've I'll have to go back and ask that, because I'm not sure what it's like in the commercial world with obviously tax deduction for research and innovation. But yeah, no, that's a good point. But it's more of a commercial side that I'm not so au fait with.
I think there are incentives, but I don't know whether that applies to you or not. But maybe check that out, and we can get back to Tim. The next question we've got here is from David. It's more of an open question. He says, when I think about robotics and AI in construction, I think about trying to recreate a manufacturing environment. Is this really necessary? Has technology moved on so far or far enough to allow access to, hang on, I can't get the rest of it. Let me just see, I can't see the rest of the, to allow access as a human might access.
So I think what David is looking at here is the fact that you know, in a manufacturing environment, it's quite a sterile environment, because you're in one location, it doesn't change. You've got a simple process that goes on day after day after day after day. And perhaps here in the construction industry, it's a different environment, different tasks going on every day. It's not that repetitive sort of process that's going on. And I think what he's asking is, are we now at a point where robotics and AI can overcome those problems and just get on with the tasks in hand, or are we going to keep having to go back to this repetitive type manufacturing world as such? Open to anybody in the panel who wants to jump in there. I think we've lost Kevin somewhere along the line.
Yeah,
no,
Kevin,
I'm still here. Back.
Okay.
Can you hear me?
We lost your camera.
Right, okay, let's put that back on as well. Sorry. Right. So I actually think that there are opportunities around this. I think sometimes it's a mistake to think that you need to have a machine that looks like a person to be able to do different activities. I think there's lots of opportunity. For example, you know, there's manufacturers that make snake arms that might be able to get access into something in a different way to a human would, but still get that access. So I think it's a question of, if you're going to be buying robotics or developing robotics, that you make sure that you consider the sort of activities you need to do and make something that's going to be flexible enough to meet your needs. But I think, you know, obviously manufacturing, they are able to go down to some very specific cases because of the volume, whereas we've got if you're in an unstructured environment, doing the task might not be to the same frequency as a manufacturing site might be, but you've got the added requirements of the need to be maybe mobile or power supplies and things. So it's horses for courses.
But doesn't this sort of
I think there's
for the
I'm
modern
sorry, go ahead.
construction and the fact off-site construction, the fact that we could go into a manufacturing environment and manufacture a lot of what we're going to do on that construction beforehand, and then it becomes just a case, almost like an IKEA flat pack when it's on site, of putting it together, which is an easier job for a robotics stroke AI platform than it would be if you just gave them a green field and said, go on, build me a house.
I think also you're going to see an explosion really in use of robotics and AI in manufacturing for a couple of reasons. Number one, the reshoring, the relationships with China. Before, we would manufacture offshore. Now there's a movement, and we suddenly realize with the pandemic, there's a lot of things I don't have here. I got to be able to make them here. And that's happening now. Companies like Apple are talking about building manufacturing sites that are lights out, no humans or very minimal humans. And in fact, there's this collaborative robotics that Cisco and Microsoft have worked with to make robots fix themselves or fix other robots. So this isn't going to happen overnight, but the automobile industry and many other manufacturing are going to be looking to onshore things here and in the UK from the developing world back to the top tier, the top 8 countries and stuff like that. So the economy is going to change a lot.
Yeah, I'd agree with that fully. I mean, even from an environmental point of view, shipping things around the world on big container ships, when productivity might mean things could be made more local, quite cost effectively, then why would you need to continue that sort of process?
And the other thing, and it has to sort of merge with robotics, but 3D printing is a type of robotics. Doesn't have any real sensing per se, but 3D printing coupled with automation and robotics. Right now, we think of 3D printers as printing, something, maybe even printing a house, but we don't think of them as a collection of 3D printers, printing pieces and then assembling them and putting together. There's several robots out there that go and take bricks and make the bricks, and place the bricks and fill the bricks in. And there's been several, 3D printed houses type movements that have happened in the UK and the US and worldwide.
Okay, I've got a question here, which Katie, are you still okay for answering questions? Oh, you're going on mute.
Yeah, I've got another few minutes, and I need to leave at 22. So yeah, I'm happy to take another.
All right, we've got quite a few more come in just. So this is from Alec. Thank you, Alec, for the question. In your experience, adoption of new technology in the capital projects area depends on alignment between owners and contractors, which is hard to achieve as long as contractors need to tender for each project on the basis of cost and schedule. They default back to tried and tested techniques to minimize risk. How do you overcome this? I
absolutely agree with you. And to be honest, we're not even at that point yet. What we're merely looking to do is just we're selecting some things. So, for example, we've got quite low productivity on things like installation of A chambers, drainage stuff. So what we're going to do is offer to Salford University some things that we typically move around on site just for the robots to have a go. Can they pick them up? Can they move them around? First step of the feasibility study. Totally agree. So much red tape. I used to work for Highways England, and that is not even any conversations we've just started to have yet. But yeah, I imagine it will be a challenge.
Okay. Thank you for that. I've got another question from Alec, but I'm going to aim this at Nick this time. How do you see AI applied to help manage logistics for military or major construction instead of the tactical area, which typically has too many unforeseeable disturbances to manage in the early development phases. Nick, did you get that?
Yeah, I did, thank you. Yeah, I definitely see AI having a use in rear logistics areas, particularly in areas like predictive planning, and of course it applies to construction sites as well. We're going to see, and I think Ian hit it on the head really, that we're going to see more AI in pre-construction. So predicting how much material that you are going to need. And then dynamically later during construction, you will see systems predicting how much material you are then going to need on site, and then you'll see things like drones or UGVs being automatically dispatched just in time for when they are needed onto site. But it in the rearward areas, it's more likely to happen than in the forward areas. I think something I'd like to bring out from earlier discussions is that in terms of implementing these types of systems on site, they're going to be used in very defined ways at first. So you're going to need to pick your use case. And in autonomous vehicles, we talk in terms of things called operational design domains. So that piece of autonomy, that feature is designed for a specific thing, a specific task in a specific context. So weather, terrain, how dynamic and unstructured the environment is. And as we move forward in complexity, so as we move forward to say the frontline areas, those operational design domains are going to get more complex. And this is the same in every sector. So the things that we need to expand those operational design domains are things like simulation and representative environments. So we can train our intelligences to operate in different weather conditions, how unstructured environments. But I think the question that was asked was spot on. We're more likely to see it in the rearward, less complex, less kinetic logistic areas first. I definitely see that as having an application. It's something we're starting to think about, very much starting to think about now.
Okay, thanks, Nick. I've got another question here, and I might just answer the first part of this, but ask Nick, Fran, and Kevin to jump on it as well. This comes from Matt. And Matt's saying, in terms of construction, is robotics a want or a need? Health and safety has generally improved, and I'll agree with that. The sliding scale over the past 20 years shows the AFR going down, and with DFMA, there's less time on site. Now, I agree with that as well. The thing is, the uptake and use of DFMA is still fairly low and slow to develop. The benefits of using it, it's great. It's got no real comparison. However, going forwards, there needs to be a lot more work done on that. I would say that there are still many operations on a project, and if you look at some of the infrastructure projects, there's lots of opportunities to employ robotics. I know there's some work being done, coming back to DFMA, on the smart motorways, where quite a lot of the stuff is assembled, manufactured off-site and then assembled. And particularly if you look at the refuge areas, that's happening. And of course, some of the other stuff that in infrastructure projects, bridge beams, for example, still made somewhere else, brought in, assembled. But there's still a long way to go. And I think the opportunities are quite vast. Kevin, Fran, anybody want to jump on and add more to that? Any thoughts
so from
on
the rail perspective? I agree with all of that. Sorry, I can't turn my camera on for some reason.
That's all right, no worries.
Yeah, from a rail perspective, for us, the biggest issues are accessibility and how much time we've got. So the railway industry generally does all the big infrastructure changes at times of national holidays, things like the big Christmas shutdowns and things. The railway shuts down for a week, and that's your best window of opportunity to do something significant. But all the other times, you're working in and around when the trains are off, or which might be for sort of 4 or 5 hours overnight, or you're working when the trains are running, which let's face it, is in the grand scheme of things isn't particularly good. So productivity is key, and if you're trying to do something worthwhile, trying to do that in 4 hours is really difficult. particularly if you've got to put in sort of preparatory work such as scaffolding or you're digging out something. So if robotics can do something without having to do the prep work and then also the kind of clean-up operation afterwards, would be fantastic.
I'd like to sort of add a bit on there, the want and the need, and I think Nikki put a kind of like thing on the head here, is that you can't just have a shiny thing because you want it. It's got to have those use cases in the first place. What are you actually going to use it for? Why do you need, what problems are you going to solve before you get on that side? Because that robotics is going to be quite expensive to buy and to develop and work out how you're going to use it and what you're going to use it for. And if you just, and we've seen this so many times with innovations over the years in the COMIT organisation, is, you know, an organisation will buy something really cool and then go, well, what can we use it for? I remember back after the Olympic Games in just after 2012, there was an organisation who I'm not going to name inherited, I think it was about 15,000 iPads off of the Olympic Games because it was just left over from all the things. And they were kind of like, we've got all this technology, but what are we going to use it for? We've got no idea. And they just sat in cupboards for months and months and months because there wasn't that use case in the very first place. So you're right, Matt, in the fact that we've got to think about what do we actually need to do rather than what would really, you know, all be nice. I mean, I'd love to have loads of construction taken over by robotics, but is there value in it? And can we look at that value case right from the very beginning?
Oh, yeah. No, I agree. I've got a couple of, I've got one statement and one question from Francis. Francis says construction innovation is externally driven from outside the industry. Yeah, I would agree with some of that. A lot of the drive it comes from the clients. You only look at what the UK government does, and that's got innovation at its heart in respect of procurement of projects. What I will say is, just going on to Francis' second part, he asked the question, I'm going to aim this at Kevin if I can. What is the role of education in bringing about the next generation of AI and autonomous delivery in construction? Kevin?
So, yeah, absolutely key. So one of the big problems with the rollout of this sort of technology is there's just not enough people around who knows much about it. So, yeah, and you've got two groups really. You've got the people who are going to create this technology, but you've also got to educate the people who are going to be the end users for it. So we actually need to rapidly increase the capacity in our education centres to be able to do that in all different levels, you know, from sort of doctorates and graduate students and also apprentices and technicians. You know, they've all got to learn how to use this stuff, and the people operating it too. So you've got the kind of operation aspect, you've got the maintenance aspect. So yeah, we need to completely increase those numbers. It's one of those sort of self-fulfilling prophecies, really, isn't it? Nobody uses it, therefore there's not much demand for that stuff, therefore there's no products. Start to unlock some of these things, and you start to unlock why we could get some benefit from this stuff.
Yeah, well, you know, Fran is a great exponent of the education with robotics and AI.
Yeah, oh, boy, you hit on it. In fact, I would make the argument that what we lack is really good teachers to push them. This generation, the same way in previous generation, you know, we taught them computers, and that was Mavis speaking teaches typing or something like that. They learned it on their own. There are STEM workshops. I have STEM material and stuff that I can teach kids that's been produced. AI. Why we need to get the industry, everybody here, everybody that knows nothing about robotics, everybody that knows nothing about AI, and throw them in, give them the material, and teach it. By teaching it, you know, if you can't do it, teach it. Then you'll learn very quickly how to teach it. Kids are amazing. My grandson, my granddaughter, they're doing different things with robotics now. They don't think of it as robotics the same way that, you know, people didn't think about learning about computers the previous generation. So with the proper education in the system, and it's probably going to happen outside the system. That's what's happening. It's different robotics organizations, it's different organizations doing STEM stuff. Corporate America needs to go and step up and actually working with some people on doing some of this. I think you saw, I didn't put it on there, but working with somebody now, they're doing STEM stuff. They're taking a trailer, a mobile trailer with 3D printers and die cutters and some robotic stuff. And they're teaching these kids different things. They're teaching them how to read blueprints. And how they're doing it, they're giving them a blueprint of a park or an area or something like that. And then they give them a number, and the number's on the map, and then they have to go read the map and find out where it is. And if they do it, they get a prize. Simple things like this that can get people, young kids, excited. And it doesn't take much, believe me. They want to get their hands involved in this. They want to get their brains thinking.
So, Nikki, you're quite close to the educational world with the chain organisation that you run. So, kind of having links into a lot of the universities. And are they doing things? Is there frustrating, in the fact that we have special modules on BIM when actually BIM should be incorporated in everything anyway? Is there's kind of like special stuff in robotics, whereas robotics ought to be incorporated in everything we're doing at the moment? Is the future looking good?
So from my MSc 5 years ago, and then did a mechanical engineering degree before that. And when I did my mechanical engineering degree, there was actually very little robotics, but I remember feeling at that stage that why aren't I getting taught any C? Why am I not getting taught MATLAB? Why am I not getting taught the basics of electronics? And it took me having to go and do an MSc in robotics to then learn about the robotics to learn about electronics and coding and VR and 3D things. But the graduates that I'm seeing coming through now into my work, things are starting to bleed across into each other. So you do see mechanical engineers with coding skills, because traditionally it's been the electronics students that have done all the coding, but thankfully now I'm certainly starting to see mechanical students with a knowledge of coding. But one thing I saw over in Canada was a series of civil engineering PhD students, but they were starting to use mobile robots to spot cracks in buildings. I thought that was a really interesting skill set, that these guys had gone from civil engineering and then had to teach themselves mobile robotics. So those guys could cover basically everything. They've got the mechanical skills, the electrical skills, and the civil engineering skills. I think we are going to need more people like that to break down these silos. But yeah, certainly when only 5 years ago I wasn't seeing that so much, and then now I'm starting to see people bleed across into other disciplines, which is exciting.
So I've got a question for each of our panelists in turn, really. If you could predict the next thing that robotics is going to do for construction, okay, the big impact that it's going to have, what would it be? I'll start with Kevin. What is going to be the thing that what am I going to see on a construction site in 5 years' time? Lots of.
Well, I think we might start off more with inspection type of robotics before we maybe start seeing construction. I might be wrong there, but so say self-climbing robots, and then maybe from a construction side, maybe start to have things like digging machines and heavy plant control.
Gotcha. Okay, Fran?
Yeah, my experience has been recently, and it just dawned, we partner with a lot of educational institutions, Penn State and VT and UT Texas and all, and using our software to learn data, knowledge, and integration with FM systems. And of course, the FM space, the facility management space, is aging. You know, the guys that know how to take a wrench and bang it the right way, they get that thing running or whatever, or they have some intimate knowledge of the building and the automation systems, they're all retiring the workforce. People coming in to replace them are coming, and I'm seeing this being developed, more from the technical college schools, the community college schools. They're going to 2-3 year focused, degrees and really learning hands-on. That's where the action is. And they're teaching, when they teach mechanical engineering and all, they teach it based on building automation systems and how you connect those things and electrical systems. And that's like going to be the source, especially with the big university, the 4-year traditional degree. It's just so expensive. I think the hot spot for engineering, for construction, is going to be in this mid-tier associate community college, technical college. That's going to breed a lot of millionaires. A lot of guys will go out. They're going to make a lot of money because they're going to have the mechanical, physical skills combined with the intellectual skills to build other things.
Yeah, cool.
So in terms of physical things, sorry, is that?
What are you going to see on a construction site? If I'm going to walk on a construction site in 5 years' time, and there's going to be something that's being done by robotics, what do you think it's going to be? I thought Stuart was same time. So in terms of physical things, I think we're going to see more drones. I definitely think it's going to be flying robots, but actually I think the real things that are going to make a difference, you're not even going to see. I think it is going to be the robotic process automation that's going to make a real difference. Like the question that was asked to me, the logistics planning, your Internet of Things, your connected machines, but all that processing, all that data is going to go somewhere else, where it's going to be processed on a server. I think it's going to be things that you don't see that are going to be making the real difference.
Yeah, and I think with the drones that will evolve. I don't think today, there's lots of jobs for drone pilots with the services and things like that. But the future with drones is going to be swarm or cooperative drones where they're programmed to go cover a whole area, either a specific path or a random path, for security, for scanning a whole area. If you have acres and acres and acres of stuff to scan, you don't want to be standing there and flying one, having it land. In fact, there's a company, we had them recently on one of our virtual fairs. It's Fly Echelon. I had mentioned them before. They have a battery changing drone. So you can send a whole bunch of drones up, have them come back after, when the battery gets loaded back into the dock, change the battery, and up again it goes. Totally automated, totally coordinated. You can coordinate it with 3 or 4. They originally were doing it for large scanning, construction, things like that. Last couple years, it's been focused on security, border security, and other areas, large campuses. How do you police a large campus today? It's going to be swarm type drones that are programmed, and land vehicles too for inside buildings and things like that. Even inside warehouses, one of the things with drones, they're using them for inventory. They're taking and they're flying through, and barcodes are on the outside, and as they fly through, they're able to count or read the barcodes just as they fly down through a whole area. There's 2 or 3 companies that are doing that kind of thing now. Think about doing inventory like that in a warehouse.
Well, thanks, guys. We're just about, we're almost out of time. I just want to wrap up the last few slides to say thank you. So thanks for the questions. There is still a few questions here that we'll answer offline and take up individually. So thanks for everybody putting those together. There's a few people I want to get a chat offline with as well that have asked some questions, and I'll do that. I'll follow up in the next few days or next week. Thanks to the sponsors, O2 and Rebim. Next session in March, watch out for that. And of course, join the conversation. So the only thing left now is to say thanks to Fran, to Nick, to Kevin, to Katie for participating today. Very much appreciated. Some really, really good content. The video we will share online on Monday. Thanks to Ian, thanks to Jerry. I think we've had a great session. Judging by the number of people that joined this today, it's yeah, what a fantastic turnout, brilliant all round. So really appreciate it. And until next time, anybody else has got anything else to pitch in with, I'll just say cheerio. Thank you.
Brilliant. Thanks very much, Stuart. Really appreciate it. Thanks, Nikki. Thanks, Fran. Thanks, Kevin. Thanks, Katie
Keep
and Jerry.
safe, everyone. Keep safe.
Take care.
Thank
Have
you.
a good weekend.
Bye.
Great weekend, everybody. Thank you. Bye-bye.
Yeah.
Bye.
Bye.